So an example of drawing an alkene. So I know this is an alkene because I've got the ending "ene" here. The next thing I'm going to look at is this part, the hex. So hex tells me that my longest carbon chain has 6 carbons in it. So the first thing I'm going to do is draw out a carbon chain with 6 carbons in it. And make sure, double check that, make sure that you've got 6 carbons in it. And the next thing I'm going to do is, I know there's a double bond in there somewhere, so before I put in all my other bonds, because I only want 4 bonds from each carbon, the next thing I'm going to do is place that double bond. So what might be better to do here is number them first. I'll number from the opposite side than I did the last one, so I'll do 1, 2, 3, 4, 5, 6. And so what the 2 up here means is that my double bond, the 2-ene, means that my double bond starts on carbon 2. So I go into carbon 2 and that's going to have my double bond on it. Now, some people get confused because they say, how do I know it's on that side of that carbon rather than on this side? If it was on this side, that would be hex 1-ene, because as soon as you get to carbon 1, you'd be touching off the double bond, you'd be bumping into the double bond here. So it can't be in between here, because then we would start counting from here, we would hit it straight away, and that would be hex 1-ene. We wouldn't need to jump to the second carbon before we would hit the double bond. I hope it makes sense the way I'm explaining that. Okay. The next thing I'm going to do is draw in all my other bonds to make sure at the end that I have 4 bonds coming from each carbon. This one I already have 1, so I'm going to just add on 3 other bonds there. This carbon, I've got 2 bonds coming from it. I didn't draw that very well. 2 other bonds needed. Carbon 4 has 2 bonds as well, so I'll need another 2. Now be careful here. Carbon 3 has 1 single bond over to carbon 4, but it has 2 bonds going to carbon 2. So carbon 3 only needs 1 more bond. That's 1, 2, 3, 4 bonds coming from that carbon. Carbon 2 is the same. It has 1, 2, 3 bonds already. And I'm going to put the extra one that it needs going down, so that I'm just giving myself space there to make my drawing as clear as possible. That since they're both right next to each other, I'll spread them out. I'll put one going up and one going down. You'll learn more about that if you study this at university level, but for now we won't go into the reasons why. And then carbon 1 only has 1 bond coming from it, so we'll throw 3 bonds on there so that we remember at the end we have to fill that up. The next thing I'm going to look at is my substituents even. So I know I've got an ethyl group. I know eth means that it has 2 carbons. So it's going to have a carbon attached to another carbon sticking off. And I need to fill up those bonds those carbons as well. So that needs another 2. So that'll be CH2. This one only has 1 bond, so that'll be CH3. So that's what an ethyl group is. It's 2 carbons that each need to be filled up, that they're bonded to each other, and they each need to have enough hydrogens to fill them up. So my ethyl group is going to be attached onto the 4th carbon. So I've already got them numbered, but just double check again. 1, 2, 3, 4, and my ethyl group is going to be there. It doesn't matter whether you put it going up or going down. The same for these. I could have put this one going down, that one going up. None of that matters. All that matters is that you go to carbon 4, and just for space, because I've written up here, I'm going to put it sticking down. And so I've got 2 carbons attached onto carbon 4, eth, 2 carbons, and I'm going to fill up the bonds there as well. So that's me done basically. All that's left now is to fill in all the blanks with all my hydrogens. So I'd start filling in all of my hydrogens here. I'm not going to make you watch me do it all. You need to fill in all your hydrogens all around here.